on Wednesday when I said you can take the factors of that last term and they should be, they're all of the possible factors or of the polynomial. That's actually called the rational zero function. So every rational zero is of the form p over q, so it can be a fraction or a whole number, where p is a factor of the constant term and q is a factor of the leading coefficient, which we'll go over in a second. And then the corollary, a corollary to a theorem is like kind of like a little side note, you know, or a PS. If the leading coefficient is 1, then the factors, the rational zeros all have to be factors of the constant. Okay, so what we have here is we have this polynomial, and so what you do is you list your factors of 16. So there are 1, 16, 2, 8, and 4. But then you also have -1, -16, -2, -8, and -4. And then you list the factors of the leading term, which is 4. So I have 1, 2, and 4, and then -1, -2, and -4. So then what I do is I take all of my factors of 16 individually and divide them by all of my factors of 4. Now sometimes it doesn't make any, like 16 divided by 2 is just 8. And 8 divided by 2 is 4, and 2 divided by 2 is 1. So I really don't have, in this particular instance, everything will divide by each other. Does that make sense? So 1 divided by 1 is 1, but 1 divided by 2 is 1/2. So I'm going to have that 1/2. 16 divided by 2 is 8. We already have that. Or sorry, 1 divided by 4. I'm skipping. Sorry, 1 divided by 4 is 1/4. 1 divided by -1 is -1. We already have that. 1 divided by -2 is -1/2. And then 1 divided by -4 is -1/4. And then I go through and I do the 16. Well, 16 divided by 1 gives me 16. 16 divided by 2 gives me 8. I already have that. 16 divided by 4 gives me 4. So if I'm dividing 16 by these, I'm getting whole numbers, so I'm done. If I'm dividing 2, that gives me 2, that gives me 1, that gives me 1/2. I already have all of these. Same with the negatives, I already have all of those. If I divide 8 by each of these, I get numbers I already have because they divide evenly. And then if I divide the negatives, well, 1 divided by 2 is, or -1 divided by 2 is -1/2. I already have it. Do you see what I mean? So you don't have to list them all a million times. Once you've found all of your possibilities, then you just go through and you list every single possible factor. And these are all of the possible rational zeros. So basically what we said is this is P, no, sorry, this is Q, and this is P, and we want to do P over Q. So basically then, when you're trying your synthetic division, this is the pool of numbers that you would pull from. And these are going to be all of your rational ones. Now that's not to say you can't get irrational, you know, square root answers or complex, but this is all of your rational ones, all of the numbers that are going to be a nice, even, pretty whole number. Here we have a 1, right, an invisible 1. So all we really need to worry about is the factors of 12. So the factors of 12 are 1, 12, 2, 6, 3 and 4, and then -1, -12, -2, -6, -3, and -4. And because my leading coefficient is a 1, I don't have to divide anything. So these are all of my possible zeros. Rational zeros. Find the possible rational zeros, then we use the synthetic substitution to figure out which ones are actual zeros. So here we have like a word problem. If Adam is building a computer desk with a separate compartment for the computer. The compartment for a computer is a rectangular prism, which is basically a cube except it's a rectangle. And it will be 8,019 cubic inches. So we need to find the dimensions of the computer compartment. And you know, we find volume of a cube or rectangular prism is length times width times height, right? So length times width times height is going to give us this. And we want that to equal 8,019 cubic inches. So first I need to multiply all this back together. So I'm going to FOIL it. And then combine like terms. And then distribute in that last x. And finally, I need to set it equal to 0. Then I FOILed, so you go first, and then outside, and then inside, and then last. And that gave me x squared plus 24x plus 18x plus 432, because 18 times 24 is 432. And that equals 8,019. And then I add my like terms together, so that's this 24x and 18x. That's how I get 42x. Okay. Then from there I distribute in this last x that's just been hanging out on the outside. So multiply everything times x. So it raises the exponents. So this becomes x to the third, x squared, and then this last 432 gets an x. And that's still equal to 8,019. But then I need to set the whole polynomial equal to 0 in order to be able to solve it. So I subtract that 8,019 from both sides. Alright, so from there, we've now got this x to the third plus 42x squared plus 432x minus 8,019 is equal to 0. I need to find my factors of 8,019 in order to know what possible factors I can divide by. So we're going to make a factor tree. It's the easiest way to do it. Okay, 8 plus 0 plus 1 plus 9 is 18, which will divide by 3. So this whole thing divides by 3. So I get 2 with 20, so that's 6 with 21, so that's 7, and then that's 3. this is 8 plus 7 is 15, and that's 18, so this whole thing will divide by 3 again. 3 goes into 26 8 times 891, which adds up to 18, so it'll divide by 3. 297, which adds up to 18, so it'll divide by 3. And I get 99, which will divide by 3, and I get 33, which will divide by 3, so I get 11. Okay. So I now have the prime factorization. How does this give me a list of factors? Well, my first two factors, oops, that's not my first two factors. My first two factors are 1 and 2006, no, 2000, 1 and 8019, and I also have -1 and -8019. Because these two make that negative and these two make the negative. Right? My next two factors are 3 and 2673 and -3 and -2673. Then I have 9. Do you see that? If I take these two and multiply them together times 891, I would get, does that make sense? So I have 9 times 891 and -9 and -891. And then I have another 3 that I can take from here and give here. So I have 27 times 297 and -27 and -297. And then times 3 again. So I have 81 and 99. Times 3 again. Hold on. Gives me 243 times 33. And then the last one, sorry, that should be negative, is negative, or 729 and 11 and -729 and -11. Now, are you going to end up trying every single one of these? No. Now we look at our leading coefficient, but our leading coefficient is a 1, so we don't have to divide anything. So these are all of our possible factors, or our rational zeros, rather. They're rational factors. Okay. All right, so now we take our possibles, and we're going to try synthetic division. So again, our original oops, nope, I'm writing the wrong original. I'm writing the stupid original that is not the original. Sorry. It was x to the third plus 42x squared plus 432x, right? Is that, did I write those down correctly? Yeah. Okay. And I have that big long list of factors, which I'm not going to rewrite here. And if I start with 1, is it very likely that I'm going to get to positive 8019 and cancel out? No, it's not very likely. So I'm not even going to bother with my 1s. I'm going to start somewhere I think kind of in the middle-ish. Maybe 27 or 81, 11, 99, something a little bit bigger. In hopes to get this 8,019. And what I'm going to do to try to figure it out is I've got this 42 that I'll be multiplying by something, and this 432-ish number that I'll be multiplying by something, you know, somewhere in there. So I'm gonna divide 8,019 by 432, and that's not going to give me an exact, but it'll give me a let's start around this point, sort of an idea. Does that make sense? Okay, so I'm going to pause a moment while I do that division. Okay, so this is about 18, so I'm going to try 11 and just see what happens. So I've got 1, 42, 432, and then negative 8,019. 3, 2, 1, none. Okay. Just double checking to make sure I have all my variables. Okay, bring down that 1, and I get 11, which gives me 53. So that's 583. Okay, this is probably going to be too big. Yeah, this is going to be too big. $70,000. 70 blah 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 blah. Not zero. Okay, so I'm gonna go down. Okay, so I'm gonna go down. I did 11, so I'm gonna try 9 now. Does that make sense though? Like I'm, you know, trying to narrow this down so that I'm not sitting here multiplying every single thing. That's going to be 51. So that's going to be 561. So it's going to be 993. Too big. All right, well, let's try 3. Oops, that's 1. That's 3. Okay. So I am now too small. Did you see that? Did I make a mistake? Where? 9 times. Didn't I do that on the calculator? Oh. I thought I did that on the calculator. Was that 459? Yeah, 459. Thank you. All right. So we've got 9. So 9 works. So far our factorization is x minus 9 times x squared plus 51x plus 891 equals 0. Okay. Now we could try to factor this and find the factors of 891 that equal up to 51. We kind of already have factored this. If I go backwards, the factorization of 891 is down here. Do you see that? So I could figure out which of these add up to 51 if we want to, or we can solve it with quadratic formula. Which would you guys prefer? No preference? Okay, quadratic formula. So, hold on one second. So we have x minus 9 times x squared plus 51x plus 891 is equal to 0. So that means x minus 9 equals 0, and x squared plus 51x plus 891 equals 0. Well, this one's nice. X equals 9. So here we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 51 plus or minus the square root of 51 squared minus 4 times 1 times 891 over 2 times 1. Okay. 51 squared is 2,601. And then I have 4 times 891. So minus 3564.
What was that number?
2,601. Let me fix it. And this is all over 2. So it is negative 51 plus or minus the square root of negative 963 over 2. And we have to see if there are any perfect squares in 963. So we get negative 51 plus or minus 3 times the square root, 3i times the square root of 107 over 2. So our final answer would be 9 and negative 51 plus or minus 3i over 107, or sorry, times the square root of 107 over 2. Now, that's what x equals. We're talking about the length of a cabinet. Do you think anybody measured out this imaginary number when they were building a cabinet? No. So really, we need 9. And if you go back, remember the width was x, and was it the length was x plus 24, right? And the height was x plus 18. So that's 9. 9 plus 24, and 9 plus 18. So this is 33, and this is 27. So it's a 9 by 33 by 27 inch cabinet. All right, so finding all the zeros. If we want to find all the zeros of this, we have to find the factors of 36, or rather negative 36, and we have to find the factors of 5. Well, the factors of 5 are easy. We have 1 and 36, 2 and 18, 4 and 9, 3 and 12, and 6 and 6. And then you have negative 1, negative 36, negative 2, negative 18, negative 4, negative 9, negative 3, negative 12, and negative 6.
Where'd you get these numbers?
These are the factors of 36, 36 right here. And then factors of 5 are 1 and 5. You also get negative 1 and negative 5, but because I've got all positives and negatives up here, I don't really need to deal with the negatives down here. Does that make sense? Because let's say I do 1 divided by 5, that's going to give me 1/5. And if I do negative 1 divided by 5, that's going to be negative 1/5. But then if I did 1 divided by negative 5, I get negative 1/5. So it just repeats the signs. It's really unnecessary. So we'll go through. Don't need to divide anything by 1. I already did that. So now I start dividing by 5. So I have 1/5. And then I also have negative 1/5. And then I'm going to start putting these in numerical order, sort of. And I have 3/5 and negative 3/5 and 4/5 and negative 4/5 and 6/5 and negative 6/5 and what comes after 6? Oh, 9. 9/5 and negative 9/5 and 12/5 and negative 12/5.
What is this?
These are all the possible zeros. To find all the possible zeros, you factor the last term and the first term, and you divide all of these by these. So right now I'm dividing by 5, which is giving me all of my fractional possibilities.
You divide by 1.
Yeah. So 18/5 and negative 18/5, and then 36/5 and negative 36/5. And 1 and negative 1 and 2 and negative 2 and 3 and negative 3 and 4 and negative 4 and 6 and negative 6, 9, negative 9, 12, negative 12, 18, negative 18, 36, and negative 36. These are all the possible zeros. Or sorry, all possible rational I need to keep throwing that in there. It's all the possible rational zeros because there's still the possibility of irrational and imaginary. Okay, so now that we have all the possible, all the possible zeros, let me write this down really quickly. Actually, all right, we're going to try to figure out which ones they are, and I'm going to start with the small ones, work my way up. And not small as in fractions, I mean small as in 1, 2, 3. So I'm not writing very well today. So I have 5, negative 8, 41, negative 72, and negative 36. So we'll see what 1 gives us. Um, 38. Sorry, I'm just double checking myself. Okay. So let's try 2. Perfect. Found 1. So what we have right now is x minus 2 times 5x to the third plus 2x squared plus 45x plus 18. Does everybody have that? Okay, so now I'm going to do the same process. Now I have the same list, right? Because these are all possible factors. I don't have to do this list over again, but I can if I want, because I can narrow it down now to anything that would be factors of 18 or 18 over 5. So I don't have to try, 36 anymore. So I didn't try 3 yet, but these are all positive, so I don't think 3 is going to be a good match here. I didn't try any negative numbers yet. So I'm going to try maybe -1 and just see what happens. Okay, that didn't work. maybe -2. Yeah, that's not going to work. Right, because I'm going to get -122. Okay, so we could try three, but I think any positive number I get is going to get giant, right? Do you see that? Because I'm going to do 3 times 5, which is going to be 15, 17 times 3 plus 45, and then times 3. It's going to get really big. And my negative numbers, as you can see, are getting too big negatively. So I've pretty much eliminated all of my whole numbers at that point, just reasoning it out. So I'm going to have to start with my fractions. 3/5 and 4/5, do you think? I'll try 3/5. So that's 3/5 right there. That's a 3, even though it doesn't look like it. Okay. So -3/5 times 5 is -3, which is -1, times -3/5 gives me 3/5. So 45 times 5 is 5, carry me 2. So this is going to be 228 fifths times -3/5. So that's going to be -684 tenths.
Wouldn't you just add 45
I did.
multiply it?
I did. But you can't multiply a mixed number, right?
Oh, okay.
So I had to make it improper. So 45 is 225 fifths, and then I added 3/5 to that to get the 228. And then multiplying that by 3/5, I get -684 tenths. It didn't work. I'm going to just try 1/5. It's possible that it's 4/5. I don't remember, but I'm just going to try 1/5 and see what happens. If I multiply that by 5, I get 1, which gives me 3. When I multiply that by 1/5, I get 3/5, which gives me the same exact thing. So that's 228 fifths, but when I do that, I get 228 tenths, but it's positive, so it doesn't work. Let's try negative. Or we could factor by grouping. Do you see it? If I take a 9 out of here, I get 5 and 2. Do you guys see it? Do you want to keep doing this, or do you want to factor by grouping? Grouping. Okay, from 5x to the third and x squared, I can take an x squared, and that leaves me with 5x plus 2, plus 45x and 18, I can take a 9, and that leaves me with 5x plus 2. So this is x minus 2 times 5x plus 2 times x squared plus 9. Those would all be equal to 0. Negative 2/5, which we would have gotten to in 2 more tries. So our zeros so yeah, I was trying the negative 1/5, right? And next I would have tried 2/5, and then next I would have tried negative 2/5, and negative 2/5 would have worked. But then I saw the lazy way out. Bet you never thought factoring would be the lazy way out.